Okay, so hi, let's do this question, right? We have this circuit and we need to find the voltage across R4. So R4 is over here, and yeah, so we have two voltage sources, one 9 volts, one 10 volts, and we will use the superposition theorem to let them take turns, right? Having their contribution to the circuit. At the end of it, we find the total voltage across R4 by summing up the contributions from 10 volts and from 9 volts. So first step, right, is to turn on the 9 volts, right, and turn off the 10 volts, right? So we let them take turns, right? So let's redraw the circuit. So when we turn on the 9 volts, we're going to get this one being 1K. I'll leave out the ohms, but all of the resistor values have ohms. This is going to be 1.5K. This is going to be 2K and 2.5K. Okay, and okay, so then what about this? So we have a 9 volts over here, and then the turns you turn off the 10 volts, right? When you have 0 volts across the two terminals of the 10 volt, so it's as good as joining them up with a conductor, a short circuit, right? So yeah, so now we have this circuit. Now what is left to do is to calculate the PD across this 2.5K resistor. So what's the PD across the 2.5K resistor? First of all, we realize that these two these these two branches are in parallel. So okay, so this is in series, right? So it forms a 4.5K resistor. Then next, these two are in parallel, right? So if we withdraw the circuit, then withdraw the circuit, then it's as good as replacing it with an effective resistor. So you have a 1K over here, and then it goes here, and the red one is replaced by effective resistance of, right? So what is that? The red one is going to be 1 over 1.5K plus 1 over 4.5K, right? And that is going to be, so let's punch in our calculator. So that's going to be 1.125K, 1.125K. Okay, so lastly, these two resistors are in series. So we have these two resistors in series that gives us 2.225K ohms, right? And once again, with the 9 volt battery. So yeah, so now we can calculate the current flowing through calculate the current flowing through the 1K ohm resistor, right? So what is that going to be? I is going to be, right? This I is going to be 9 divided by 2.225, and that's going to give us 9 divided by that. That's going to give us approximately 4.2353 ampere. Oh, actually, it's actually going to be milliamperes. Yeah, because we are talking about this 1000. Yeah, so let's not forget the milliampere. Okay, so then now we know that. So now we know the current flowing through the 1K ohm resistor. So let's calculate the potential difference across the red resistor. Okay, so so the potential difference across the red resistor, right? So PD across the red resistor. Okay, so let's calculate the PD across the red resistor. Let's call it V, right? V V V red. V red is going to equals to 9 minus 4.2353 times 1K. So that's because you can calculate it using the voltage divider principle as well. So you take 1.125K over the total, which is 2.225K, then multiply by 9, that will give you this, that will give you the same result as well. So you have this is, don't forget the milliampere there. So 9 minus, so that will give you 4.7647 volts. Right, so that's the voltage across VR. That's the voltage across the red resistor. Right, so now we know that the voltage across these 2 points, in the circuit is 4.76 volts. Right, so all that remains is to calculate the current through this by finding the current through the 2K and the 2.5K. So let's take the the current flowing through the blue part of the circuit, right? I is going to equals to 4.76 divided by 2K plus 2.5K is going to give you it's going to give you 1.0588 milliampere, right? And to find the PD, right? PD across the 2.5K, right? So lastly, to find the PD across the 2.5K part, let's choose pink. So to find the PD across the 2.5K, so the PD across the 2.5K is lastly going to be your I, the current I. Okay, your blue current I. So 1.0588 milliampere times 2.5K ohms. And that's going to give you 2.647 volts. Yeah, 1 volt. Okay, so that's the result of the first scenario. So the first scenario tells us that the potential difference across the 2.5K resistor R4 that we're interested in, right? This one is 2.6471 volts. That's for the first scenario, right? Where we turn on the 9-volt source only. Okay, so now let's consider the second scenario, right? Where we turn the 10-volt source on and the 9-volt source off. So second scenario, 10-volt on, 9-volt off. So what happens is 1K, then we have this, so 1.5K, then we have 10 volts, and then 9 volts is now replaced with a 0 volts, right? So it's a short, and then you have your 2K, 2.5K. So let's go through the exact same procedure, right? So once again, this part forms 4.5K, 4.5K, right? And then your 4.5K parallel with your 1K will give you, so 4.5K parallel with your 1K resistor over here. So now when you consider in parallel, that'll give you, right? So 1 over 4.5K plus 1 over 1K equals to that's going to give you around 818 ohms. Yeah. So so from there, right, that thing is in series with your so from there, if we redraw the circuit, it's going to look like this. So when we redraw the circuit, it's going to look like 10 volts, right? And then you have your 1.5K, and then, right, the rest here, this is your 818 ohms. So yeah, so now it's in series. So this one we just add up with the 1.5K. So we get, right, in the end we get so 818 plus 1.5 1.5K gives you 2318. Okay, so 2318 ohms. So then you calculate the current through the 1.5K, right? So your current I is going to equals to 10 volts divided by 2318, and that's going to give you 0.043. Okay, so let's write it in milliamps. So they're going to give you 43 point, 43 point, no, sorry. It's going to give you 4.3137 milliampere. That's right. So yeah, so now the voltage across the 818 part, right? The voltage across the 818 ohm resistor is going to be 10 volts minus 1.5K times 4.3137 milliampere, and that's going to give us 3.5294 volts. Okay, so that's your voltage across these 2 points. So if I could highlight it, this voltage is the voltage. This 3.5 volts is the voltage across these 2 points. It's the voltage across those 2 points. So it's the voltage across this part. So in order to calculate the current, the voltage across the 2.5K, right, we just need to do the voltage divider. So voltage across the 2.5K is going to give you, so you have your 2.5K over the over your total, your 2K plus 2.5K, which gives you 4K, or 4.5K, I mean. Then you multiply by 3.5294 volts to give you, so that's going to be 2.5 over 4.5 times your voltage, 3.5, and that's going to give you 1.96 volts. Yeah. Okay, so now we can so now we have considered the 2 scenarios, right? For one of them, let's highlight it in blue. So for one of them, you get this contribution across the 2.5K, and the other one, you get 2.64, right? So you realize that in both scenarios, right, the voltage is the top one is higher than the bottom one. So this one is the positive end, and this one is the negative end. So in this case, it's also the positive end, and in this case, it's also the negative end. So we add them up. The algebraic sum will just be the sum without any minus sign involved. So the total, right? So V total equals to your 1.96 from here plus the 2.64 from there. So that's going to give you 4.6079 volts. And that is your answer. So that is the voltage across R4 when everything, that's going to be the answer to the voltage across R4.